Now let's look at this question. This question is from exam 2005. This is question 1, and it has so many part questions. Let's work on them one by one. So what is shown here is a very typical photoelectric cell, photocell, and it is to demonstrate the photoelectric effect. Now let's look at part A. Light frequency this much is incident on the photoelectric cell. Calculate the energy of the light photons. We say that we call this kind of light that shines into this, like the circuit. We call this light incident light. Incident light. So that's the name of this kind of light. Okay, we can call it the incident light. And it has a frequency of this much, so I believe if we want to know the energy of the light photons, we can use this equation or formula. And h is your Planck's constant, so it is going to be 6 something like this times 6.16 times 10 to the power 14, and we want to do it on our calculator. 6.63 times 10 to the power of negative 34 times 6.6, should be 16, times 10 to the power of 14. Our final answer should be 4.08. Now remember, since the question gives us some numbers, values, rounded to 2 decimal places. No, we want to keep that. 4.8. It's going to be 4.08 times 10 to the power of, should be 19. Yeah, negative 19 joules. So 4.08 times 10 to the power of negative joules. And then let's look at part B. All right, part B. Each photon will release an electron. We know that. The graph below shows the relationship between the kinetic energy, this EK max, EK. Actually, it's EK, and not EK max. Is EK kinetic energy of the released photons and frequency of the light incident on the cell. So describe what would happen if light of frequency P. Now, light of this frequency P0, actually maybe it should be F0. Now F0, it is going to be the threshold frequency to make this photoelectric effect to take place. Now if your frequency is less than this threshold frequency, then we cannot see any of the electrons coming out of the metal. So we know the answer, right? Describe what will happen. Then there will not be photo emission. We can call this effect photo emission too. Okay, photo emission. There will not be photo emission. Okay, so this is how we answer this. For the third one, I believe the third one, part C, is connected with the previous one. So maybe let's try to calculate this too. Each photon of frequency this much will release an electron with the maximum kinetic energy of 0.35 electrovolts. Calculate the threshold frequency. We have done this, I believe, many times. Now, if we want to know the F0, the threshold frequency, we want to know the phi, the work function of that metal. And to know this phi, we have to, since we are given this, like preconditions, we can use EK is equal to HF minus phi, so that we know phi is going to be equal to HF minus EK. EK is given as E volts, yeah? Then F is is given 2, so we can calculate this number. Now, if you don't want to calculate the value now, we can, like keep simplifying this. We can combine this. I believe now we have our f0 is going to be equal to hf minus ek over h. So it is going to be like f minus ek over h. Then at this point you can plug in some numbers, values. It's going to be like 6.16 times 10 to the power 14 minus it's going to be 0.35 electrovolts. So we can convert it into joules, right? Times 1.6 times 10 to the power of negative 19 over h, Planck's constant. By now, I think we can remember all these constants, right? So the final answer is, let's see, 6.16 times 10 to the power of positive? Yeah, positive 14. Yeah, because it is a frequency, it makes perfect sense. Minus, yeah, ek is 0.35 times 1.6 times 10 to the power of negative 19 over Planck's constant. So the final answer is going to be 5.32 times, okay. 5.32 times 10 to the power 14 hertz. Don't forget the unit hertz, because we are calculating frequency here. So this is our final answer. Yeah, maybe let's leave the rest of the questions for the next video.